All right, hello everybody. We are talking about scraping web pages, and what that means is acquiring the text off of a web page. So I'll give you an example. If we have a nice piece of text on a web page, and we don't really need the things like the images or the color or the font, but what we care about is the text. That's what's called scraping. And so what can we scrape? Well, we can scrape just about anything that loads, right? Unless it's like dynamically loading content like Instagram or Twitter or something like that. You can still scrape that. You just need a different tool than what we're introducing. So we're giving you a way to peek underneath the hood. Notice I'm right-clicking on a web page and I'm saying view the page source. And I'm going to give you all a little intro to HTML. I know there's a lot of code on the screen, but what we're interested in is the actual text of a page. Okay, like what the links are, where those links are going, the content of articles, for example. And so as part of your lesson here, like it's important to know that we can build a body of data that's not just from CSVs, that's not just from SQL databases, that's not only APIs, because frankly, sometimes you don't always have a nice clean API or a web service, right? So I'll give you an example. If you have transcripts, like medical transcripts on the web, not medical, but any kind of like television transcripts on the web, or emails that are printed out on the web, you just grab that text and make yourself a corpus. And remember, corpus is just a body of a data set of text. So when we're talking about acquiring data through scraping, it's generally a good custom to check out the terms of service page and check out if there's a robots.txt file that the HTML links, and figure out if you should be scraping that or not. Don't want to encourage y'all to do anything unethical, but scraping is very common. I mean, it's how Google started building its empire, right? It started scraping anything and everything that it could in order to make a data set. So let's talk about some of our tools that we're going to be using. The first tool that we're going to be using is your web browser to manually load an HTML page and check out the HTML elements. Okay. What we're going to use to programmatically load a web page is the requests library. And what this is going to do is allow us to send HTTP requests over the web to a server and have the server respond back with the response. Okay. What we're going to be getting back, let me show you a little preview. This is a little example site for scraping that I made. When I view the page source here, all of this HTML here is what is delivered to your browser when you loaded a web page. Now, HTML is markup code, and so it's going to render in a browser. But what we're going to get back from scraping is all of this HTML as a single string. And then we'll talk about how to parse that string using Beautiful Soup. I see a question from David. Go ahead, David.
Hey, Ryan. Would you mind sharing that notebook, the Acquire one you're looking at, with us?
It is literally the curriculum. I would be happy to share the notebook with you, but it's like literally the curriculum.
Oh.
Yeah, it's not different. The only thing I'm sharing with you that's not linked in here is this site to scrape. This is a real basic HTML page.
Okay, thank you.
Yeah. So HTML renders to what human beings see, and we will get back all of this information from the requests library. And to parse this, remember when we introduced regex, I said, dear heavens, do not use regex to parse HTML. And I stand by that statement because there's so many different special characters, and it's just HTML and regex don't really get along. right? Because we can have special characters, these HTML tags, an arbitrary amount of attributes. Arbitrary means like 0 or more. It doesn't really matter. It can be as many as we need, right? We may even see other coding languages in here. So potentially when you go to an HTML page, you could see CSS code, HTML code, and JavaScript, right? So in order to parse the content, so imagine we get all of this HTML back as a single string, we're going to use a site called, or a library called Beautiful Soup. And what Beautiful Soup is going to do is allow us to focus in on individual elements if we want. Like maybe we just want this specific heading and just the text from that one specific heading. Or what if we want to say, hey, Beautiful Soup, select everything that's a paragraph tag. Or just give me everything that's in the main tag of a page and give me the text. So Beautiful Soup is allowing us to kind of strain through that HTML. If you have a lot of things to scrape, a lot of different URLs, or if one page has a link to the next page, then you might want to script that process of requesting another page and parsing its data. And then once we've built a corpus of text, and really what we're trying to do is make data frames of text, right? Once you've got your corpus of text, we will take that data further down the data science pipeline. So some of the steps that we're going to be working with is using the request library and the get function to make a web request. We're going to get back the HTML as a string, and then we'll parse that HTML using Beautiful Soup. And in the exercises, we're going to have y'all connecting to and scraping the Code blog and a news website that provides like summaries of news articles. And for each row in a pandas data frame will represent one blog post or one article. Okay, and the different columns could be title, content, author, date published, etc. You can make whatever number of columns that you need. It's pretty customary, so we don't have to repeat ourselves, assign the web address to a URL, make our request using get. We do want to check the response text to make sure that you have HTML and not an error message. And then I'm going to show you how to look underneath the hood of a web page and determine how you can scrape things, how you can find things on that HTML page. And I'll talk about a couple of cases where like you might not be able to scrape something, right? If you have a web page that's like Flash, if anybody remembers Flash from the Stone Age, it was an animation language it was huge in the late 90s, early 2000s. We can't scrape Flash, right? But we can scrape HTML all day long. We'll parse that HTML, and I'll give y'all some strategies for doing that. And we're going to talk about some fundamental components of HTML structure, because y'all need to know that. We don't need to make web developers out of you, and I can't do that in a day, but HTML is pretty easy to figure out. It's a markup language. It's not a logical language. And yeah, so we're going to scrape a bunch of stuff. We're going to build a corpus, and then you can analyze that corpus of text. Okay, so big picture. I'll get into code next. I want to see what kind of big picture questions are coming up for y'all right now. Or if y'all are ready to jump right in. Okay. Let's jump right in. So the libraries we're going to be using, import the requests library. And since we only need to download for scraping, like if you needed to send forms, you would use the post library, but we're just using get. And the library for Beautiful Soup is called BS4. And I want to give you all the documentation for that. So the Beautiful Soup library has some really phenomenal documentation, and it's a little bit long, so I'm not going to read it to you or at you. But Beautiful Soup is what I shared with y'all. Beautiful Soup is going to take the text of HTML and allow us to parse through that. Okay, so I want y'all to bookmark this Beautiful Soup documentation. It's really, really helpful. And then I'm also going to import the OS module so that I can talk to my operating system with Python. One of the reasons why we would want to talk to our own local operating system when we're scraping things is so that we could check for the presence of a file locally or write the presence of that file locally. And we can also do that with pandas, right? With pandas write CSV. So let's take a quick trip to the web. If I have a given URL, codeup.com/datascience/math and data science, we're going to store that as a string variable. Doesn't have to be a variable, but if we reference this URL multiple places, I just want to reference the variable. Now the headers are pretty important. When you send a request over the web, what you send as part of your request is the body of the request and also the headers. And the headers contain, at the very least, your user agent. And we talked about user agent yesterday. That's how you're identifying your client. So your browser identifies as, if you're using Firefox, it says, hey, I'm Firefox, I'm running on a Mac computer or a Windows computer or whatever. If you're using the request library raw, the user agent is actually just Python requests library. But the CodeUp blog doesn't want randos scraping it. So there's a little bit of a it's not the tightest security in the universe, but at least forcing somebody to have a user agent as opposed to the default Python request library. So that's why this header is set here. There's some other values we could set in the headers. We don't need to worry about them right now, but headers think of it as metadata about your request. And what we're going to get back from the server, even if the server is like turned off, we will get a response. And so that response, I've got to run my imports first, excuse me. What that response is going to be is one of those HTTP status codes, right? So if like your Wi-Fi is turned off, our response is probably going to be a timeout, right? Or an error that we're not connected to the internet. But if for some reason that server is not responding, it'll have a 500 level error. Or if there's something goofed up in our request, like a 404 not found. If I change the URL to data science 2 and send this, I should get back a 404. 404 is page not found. 403 is forbidden. And check out the HTTP status dogs or the HTTP status cats for a visual reminder of your status code. So response 200 is good. Anything 200 level is good. Anything 300 level is some kind of redirection where the server says, I know what you're asking for, and it's not where you said it was going to be, but I know where it is, so I'm going to redirect you. That's what a 300 level issue is. And 400 level errors is there something wrong with the client. 500 level errors, there's something wrong with the server. Okay, so check out what we get back from this response object. And I want to do a little, oh, by the way here. We want to check, like if we're scripting this, we might want to check if the response existed or do, let's see, what is that variable? Response.status code. So we could say if response, so like maybe we're making a whole bunch of requests, we might want to say if the response status code is 404, we might continue or skip to the next line of code there. Right? But if everything's cool, here's what we're really after is the response.text property or that attribute, that text attribute. And with the slicing syntax here, what I'm saying is give me the first 400 characters. Notice what we're looking at here is a whole bunch of HTML. And again, this is a nightmare to parse unless you have something like Beautiful Soup. And you're going to see information about the web page and then the web page itself. So I want to show you all a couple of things. I'm going to pull up this specific blog post in my browser. Oh, I know that person. And when you're in a browser, what you're seeing is the rendered output, right? You're seeing what the designers wanted you to see. But when we look at the page source, now this is going to work in Firefox and this is going to work in Chrome. And if you use Safari, you have to turn this on first before you can use it. But right click in the middle of nowhere and then click on View Page Source. What this is going to give you is all of the HTML for that page. And there's a lot of stuff here, right? So I'm going to show y'all a smaller site first to give y'all some orientation, just because I don't want y'all getting lost in the details there. So I right click in the middle of nowhere on my site to scrape and view page source. And I want to show y'all a couple of things. The first thing that I'm going to show y'all is that HTML pages start with doctype HTML, and then there's a tag, an HTML tag, that contains all the contents. And then there's two main chunks of HTML that y'all should know about. There's the head, and then there's the body. And the difference is the head contains information that really only pertains to the browser itself. Like you're not, other than the title of the web page, none of this is explicitly communicated to a human being. So these meta tags are communicating to your browser. They're saying use the UTF-8 character set. Be cool if you're using Microsoft Edge, which is the replacement for Internet Explorer. And then viewport, that has to do with some display for mobile. And then in the head, you're going to see other assets loaded, like a style sheet, a CSS style sheet. So think of when we talk about web pages, and I'll just give you like web development in a nutshell. The HTML is the bones of the website. It's the content and the structure. The CSS is think of that as like your clothing. The CSS is decoration. Now, how a website looks, what fonts you use, the margin, this isn't just nothing. This is pretty important, right? If a site looks nice to use, it's because somebody put effort into designing it. So the CSS is linked in the head. You might also see JavaScript linked in the head, and on a larger web page, you might see, the head for the Code Up blog is like, it's a lot of stuff. Like the head is 300 lines long. So the thing to remember is, at its simplest, the head is communicating to somebody's browser. The body is text, images, links that render for a human being. So we're really focused on what's in the body. Now, notice this kind of structure. We have the head opens with a tag, and then it has what's called a closing tag. So an opening tag, kind of like title here. See how we have angle bracket title, and then in between here we have text, and then we have angle bracket / title to make what's called a closing tag there. Okay, and there's this nested structure. So when we look at the body tag, and the indentation, if you have a nicely indented HTML page, the indentation shows you that the header belongs to the body. The first H1 heading belongs to the header because it's indented within it. On some commercial web pages or things built with like a site builder, you might not have the indentations helping you out, but that's because HTML doesn't care about the indentations, right? And some of this stuff is just plain old JavaScript, which we're going to ignore, right? We don't need to scrape JavaScript. We just need to scrape text. The header is what it says it is. The main is what it says it is. It's the main content of your web page. And then you've got a footer element for the footer. And a lot of the different kinds of pieces of HTML you're going to see containers like main or header. Those are all containers. They're like, think of them as invisible rectangles around your content. And we could style those rectangles, right, differently. That's how we get things on web pages like this yellow bar up here is a nav bar, and it's styled with a yellow background. Okay. This nested structure, we have a division element. That's what a div is short for, is a division element. And then inside of that first division element, we have an H1, which is heading. H2s are smaller than H1s, H3s are smaller than H2s, and you see a little bit of how that works. And those H's go all the way up to H6. Most content is going to come in, you might find your content in tables, paragraphs, headers, links, all sorts of good stuff. So some other tools that you might want to use in addition to right-clicking in the middle of nowhere and is what's called the element inspector, and how to bring that up. It's in the curriculum right here, Command Option U or Command Option I. Also, I believe F12 if you have a large keyboard. And here's what this is going to give you. We can right click in the middle of a page and bring up the inspect, or we can do the Command Option I. And what this is going to show you down here in these at the bottom of your screen is the rendered HTML. And this is pretty cool because we can find what we're interested in, see how the highlighting changes as I move. If I wanted to get my hands on just one thing, it's kind of small on my screen. Do y'all see the little icon with the screen and the arrow in the lower left? Click on that, and then you could highlight the thing you're interested in, like the title here. Notice once I turned on that element inspector, I'm going to do that again to repeat. Find the thing you're interested in. And I love this, like hover. The hovering here is really helpful if you're a web designer. It's telling you fonts, colors, layout information. But once you click on that content, notice my inspector down here highlighted that in blue. So if I needed to read just the text of this heading, I would get that from this particular HTML element down here. That's pretty cool. It's pretty cool. You're going to see a couple of pieces of extra information about HTML tags. And I'll give you all an example. On that site to scrape, I had a couple of links. And a link is an A tag for an anchor. And where that link sends people is the href. It's the hypertext reference. So that's the URL of where they go if they click the link. And then there's the text of the link in there, right? And we'll see very similar things on images. Like if I go to the Codeup blog here, and let's say I click on the duck, and I do inspect on the duck, we have an image tag, img, and then we have some layout information like the width and the height, and then we also get the URL. So you can programmatically scrape images from HTML too, which is pretty cool. Find out where that image lives, load it up, etc. The thing I wanted to show you, okay, do y'all notice I can't zoom in on my box down here. So what I'm going to do is just copy this out. I'm going to copy that element, and then let's see. Do y'all see my text editor, or do y'all just see the browser still? Y'all see the text editor? Okay.
You can see it.
Cool. See how this image tag has lots of pairs of information. Loading equals the string lazy. Width equals the string 336 pixels. These are called key value pairs. Kind of think of them like a dictionary, because a dictionary is key value pairs. And these are what all of these different key value pairings are called. They're called attributes. And so attributes are kind of modifying, in fact, they really are modifying that HTML element. Some of the most important attributes are SRC for a source for an image, or href if you're using a link. And you'll see a couple of other HTML attributes that really help you get your hands on things. And that's a class, which would apply to a class of elements that have something in common. And then an ID, and an ID is a unique identifier. Think of that as like a social security number or a driver's license number for a specific HTML element. So I'm going to check out my site to scrape here. Notice that in a couple of these division elements, I have an H1 with a class of first, and I also have an H3 of a class of first, right? So see how a class can apply to different elements if we need it to. Now an ID is going to be much more specific, right? Let's see if I can't find an ID on a page here. Usually IDs are, you might see IDs less because we don't want to duplicate whatever the ID's value is. But let's see, I don't have one on this example. I'm not sure if the Coda blog has IDs since it's generated using, oh, there we go. The div, you see this division with the ID of left area. So left area is only applying to this one division element. And with IDs, you might use them, web designers and web developers use them for styling a lot of the time. And interactivity, because you can hook in JavaScript to classes or hook in JavaScript to IDs. Cool. I want to check in with y'all questions so far. I realize I'm bouncing between big picture, little picture, big picture, little picture. So I want to check in with y'all and see what kind of curiosity is coming up so far before we get into more code. All right, let's get into more code. So the response text is a copy paste of all the HTML. And if there's any CSS and JavaScript, it's everything, right? Now, how do we start parsing that? Here's how you start parsing that. Notice the response text is that HTML. We're going to use the beautiful soup library. And so check out that constructor function. It's beautiful soup. And we're going to send in 2 arguments, the response content or the response text, and then the string that's saying, hey, beautiful soup, use the HTML parser. So if you were using beautiful soup to parse something like XML instead of HTML, you would say XML parser, for example. So let's see what this is going to give us. This gives us a soup object, and I'm going to show this to you. Right now, it looks like a nicer, more prettier formatted piece of text. But if we were to check the data type of soup, notice it's an object. And remember that objects in Python or in any language have properties and they have methods on them. They have attributes and they have methods. So let's talk about some of those. If we wanted to get the title from the soup made from the whole page, we would say soup.title. And notice how soup.title gets us the title tags as well. So if we don't want the title tags, we just want the string from that, we would say .string. Soup.prettify kind of pretty prints. It does a nice formatting of the HTML. And some of the other methods here, and these are really going to be your workhorses for Beautiful Soup, are find all, find, which only finds one of something, get text, or also dot text on its own. And if you know anything about CSS selectors, which I'm going to encourage y'all to look into, if you know the CSS selector syntax, dot select can give you any number of things. Like there's CSS selectors where you can say, give me all of the checked checkboxes of a page. And that's a lot of power and precision, right? So let's jump into this a little bit and show you some of these Beautiful Soup methods. Find is only going to find one specific element. So if there's multiple matching elements, it only returns the first one. That's something to keep in mind. And check this out. Find is able to, you provide in the element selector first, or the name of the element. Now, if you haven't noticed already, there's a lot of div elements on web pages. Like they're nested, they're all over the place, because they're basically just lassos for content, or rectangles of information. Now, instead of just finding the first division element, what we're doing with this secondary argument on the right-hand side, the second argument of this find function, is we're saying, hey, soup, give me back the only the division element, the div, with the ID of main content. And we're storing that to a variable called article. Now, article without .text gives you back all of the HTML tags, but we don't want that. We want just the text. So .text is the same thing as running the function. So the method getText is the same thing as the property .text. And so what we're looking at here, folks, is the pure text of that blog article. And you're going to notice there's some new line characters that you might want to trim out of there. But if we were to print this out, the printing would handle all those new line characters and formatting. All right, pressing forward. If we wanted to write this text to your hard drive, to your computer, we could use the with open Python syntax to create the file, create a file called article.txt, use the write mode, and then do file.write. And this would in fact generate a text file on your hard drive. So one of the things that I want to make sure to share with y'all is that sending web requests is very time intensive compared to things like reading a CSV on your hard drive, right? Or talking to a database on your hard drive. So if you're scraping hundreds and hundreds of articles, I'm going to encourage you to write that content to your disk. Have y'all talked about caching and writing CSVs to your file system? Maybe not. Okay, cool.
Could you use a refresher?
Yeah, you want to whether if you use the Python's built-in file writer, or you use Pandas to CSV, once you have all of your content in a data frame, it's a real good idea to save yourself the time, because what you're scraping, unless it's changing every day, you don't need to tie up your internet connection and wait a whole long time to do it all over again. So I'd make this part of your acquisition script, is the caching. Here's some code that'll help with that. If we want to package everything up into a nice, neat little function, we can say get article text, and it will check if that file exists already, and we'll read that file. So that's your caching. Otherwise, if the file doesn't exist, send that request over the internet, write it to disk for the future, and then return the text. And again, you don't necessarily need to use the built-in Python file writer. If you are scraping a whole bunch of articles and turning those into a data frame, then you could just write that data frame to a CSV file. All right. The next little piece here of the curriculum is a crash course in HTML, which I've already given you. A couple of things to remind y'all about. The head, the only piece of content in the head for a human being is the title. Everything else, like the JavaScript and the CSS, is for the browser itself. We're going to be focusing in on usually on the main, and you will see sometimes classes. And this is a real good example where each article element has the tag or the class name of blog post. So notice, so we could have other articles on this page. If they don't have the class of blog post, they're probably going to be styled differently. An ID, an identifier, allows you to focus on just one element. And let's see. One of the things that you might see, I'm going to go off-roading just a little bit because we're done with the actual curriculum here, but I want to show y'all some stuff. Remember our piece of soup that had this entire blog post from the Coda page, right? Now, how do we start getting our hands on the content? Well, remember that element inspector. I'm going to use my mouse to find the title. And looking at this, I have no guarantee that this is the only H1. It might be, but I'm pretty confident that if there are multiple other H1s on this page, that if I use the class of entry title, that's going to help me get just this one specific piece of text. So I want to walk y'all through this and provide a little bit extra guidance here. So if I want to get the, let's say the title here, this would be soup.find, and we're finding an H1. And remember that the word class is a reserved word in Python because of classes. So underscore class is how beautiful soup specifies an HTML class name, since class is a reserved word in Python, just like if is a reserved word in Python. And that class is the string entry title. Let's crank that out. So let's see, soup.find entry title. I'm doing something wrong. Entry dash title H1. Let me test this out without that class. Huh. Why is that empty? I'm going to check the documentation. Find. Let's see. Check the find documentation. Title. I don't think they changed it. Am I just remembering something incorrectly? I could be. Let me me check out that method. Soup.find with a question mark. Have y'all seen in Jupyter Notebooks or IPython, if you put a question mark behind something, you can get the method definition? Filter on tag name. Well, this doesn't really tell me what I wanted to know. Well, it is okay because there's only one H1 anyway on this page. So that's not the end of the world. Okay. So we can find the title here and get just the text. And then if we wanted to get other information about this, like when it was published, we can get our little handy dandy little element inspector. Find, hover over the thing we're interested in. And this is the span with the class of published. So I want to show y'all something. Do y'all see immediately above where I've highlighted? There's a hovering little call out that says span.published right above the date. So I'm going to teach y'all a little bit of a CSS selector here. Span.published. So soup.select. So I don't want to have to worry about class being a reserved word. So I'm going to use select. If I wanted to say, give me the span with the class name of published, check this out. So elements with dot select, elements can be selected by their name, like A for anchor tag, div, P, H1, etc. And class names use the dot syntax. So the class name, so if the class name is published, dot class is the, or dot published is the CSS selector. And I'm giving y'all just a little bit extra here. ID names use the hashtag syntax. So if we have a div with ID equals middle to denote the middle of the page, I'll just write it like that. Then we would use soup.find hashtag middle as a string. So I'm going to put this a little more concretely. So we have a span class published. We use soup.select. So select is a little bit different than find. It's using this CSS selector syntax, which I personally prefer here. Published. So check this out, soup.select. And notice this is giving me a list. It'll give you an empty list if nothing is found. So I'm going to say bracket 0.text to get just that text. And I'll say published at. Something like that. And if we needed to get the body of this, now I'm not going to do the exercise for you, but you would use the element inspector. Click on that, find the body, find the appropriate. See how that you have like little, you have containers inside of containers. Sometimes you need to find the parent container. Kind of works like file systems and folders. So there's entry content. So I'd use the find or the select, the dot select. You may find that you like one more than the other. I'm a little biased. I like the select a bit more because CSS selector syntax is pretty powerful. And then you can produce strings for all that you're interested in. And really what we'll end up doing is making a dictionary for every blog article, make a list of dictionaries. So you have a list of a dictionary for every blog article, giving you a little hint on the exercise here. And folks, if you have a list of dictionaries, you have yourself a data frame. And then you can, instead of writing just the raw text, like a schlub, you could write the entire data frame to a CSV. Let's take a look at our exercises here. We're going to have you scraping two different sources for practice. One is the Code Up blog. It's a big list of different blog articles about the different programs and stuff going on at Code Up. The second source for scraping is this InShorts website. And I want to show y'all how to access that. InShorts is a news summarization system. So when you go to inshorts.com, it looks like they're trying to get you to download the application, the mobile app. What you're going to do is click on Read Now. And the Read Now gives you these short articles. So all that we really care about is the title. And if you want to give yourself a bonus, you could do the author as a column, the published date as a title, the published date as a column. All we care about is just this little preview of text, because the rest of this entire article is on Twitter. And I don't want y'all to have to figure out how to scrape Twitter and then have to figure out how to scrape Instagram and then figure out how to scrape the print. So see how we're just scraping these summaries here. If you see something in the curriculum about categories, those categories are on the left here. So we have sports, business, technology, etc., science, whatever. Cool, cool, cool. We'll spend a good amount of time today working on these exercises. The project is going to be different from these, but I do want y'all to have very clean blog articles, very clean news articles, because we'll be working on these with the prep lesson and the prep exercises, and then also the exploration exercises in the exploration lesson as well.